welcome back. In this video, we're going to do a word problem involving radioactive decay. So let's look at the problem. It says carbon-14 obeys the law of natural growth or decay and has a half-life of 5,730 years. If we have 72 grams of carbon-14 today, find a model, y of t, for the mass of the sample that will be left after t years. So because C14 obeys the law of natural growth or decay, we know the function has to have the form y of t is equal to y of 0 times e to the kt for some real number k. And y of 0 is the initial amount. And in this problem, we know y of 0 is 72 grams. So far, we know our function looks like this. Y of t is equal to 72 times e to the kt. Now we have to find that number k. First of all, let's think about the problem. Carbon-14 is a radioactive substance, and every living organism has a certain amount of carbon-14 or C14 in it. But when the organism dies, the level or the amount of C14 present starts to decay. And function is going to be a decreasing function. So we know that means that k has to be a negative number. Hopefully when we find it, it will be negative. Also, what does the half-life mean? Half-life of a substance means the amount of time it takes for the amount of the substance to decrease to half of the original amount, so to be cut in half. If the half-life of C14 is 5,730 years, that means y of 5,730 years is going to be half of what we have right now. So it's going to be half of 72 grams. So 5,730 years from now, there's going to be 36 grams left. Okay. So we can use that information in our function to figure out what k is. So let's plug it in. If we plug in 5,730 years into our function, we're going to get 36 grams equals 72 times e to the k times 5,730. All right, so now we can solve that for k. Let's first divide both sides by 72. So 36 divided by 72 is 1/2. We get 1/2 equals e to the 5,730k. And now, to solve this equation, we have to take the natural log of both sides. So the natural log of the left side is equal to the natural log of the right side. And now on the right side, when you take the natural log of e to the something, you just get the something. So we have natural log of 1/2 equals 5,730 times k. And now all we have to do is divide both sides by 5,730. So 1/2, natural log of 1/2 over 5,730 is equal to k. And now we're not putting that in our calculator. We need an exact number so that if we use the function to find the level of C14 after a certain amount of time, we're going to have a better answer. We don't want to approximate this. Our answer for our function is y of t equals 72 times e to the natural log of 1/2 over 5,730 times t. And now you may be wondering why that number that we found, k, doesn't look negative. I told you that this was a law of natural decay problem, and that when you have a decay function, that k in the exponent has to be negative. Well, think about the natural log function. So if we look at the graph of y equals natural log of x, remember it has an x-intercept at 1. So for any x greater than 1, the y-coordinates are positive. The natural log of a number greater than 1 is going to be a positive number. But the natural log of a number less than 1, between 0 and 1, is going to be a negative number, and 1/2 is between 0 and 1, so the natural log of 1/2 is actually negative. Another way to see it is we can rewrite 1/2 as 2 to the negative 1. So natural log of 1/2 is natural log of 2 to the negative 1. And using properties of logarithms, that's really negative natural log of 2. So k can be written as negative natural log of 2 over 5730. And so we could write our function as y of t equals 72 times e to the negative natural log of 2 over 5730 times t. And so then it looks more like a negative number. All right. So we'll see more examples of functions that obey the law of natural growth or decay in some other videos, and I'll see you there.